Hello everyone. Today again we will look at the second unit of robotics and automation course. This is the second episode of unit 2. Okay, there is a previous episode which we have already talked about in the unit 2 where we have introduced about the robotics. Now we will move on to the second unit and second part. This, as we discussed earlier in the previous episode itself, the second unit of the syllabus is given like this. In this particular unit, we will be looking more about the robo configuration and the specification of a robo. How do you buy a robo? Okay, well, how do you look for the various features inside a robo? Now, that is what we are going to look at. And the various configuration, the Cartesian, cylindrical, polar and the articulate type of robots we are going to look at. Now, just a recollection of what we said in the previous slide. We were just to recollect, we have this Isaac Asimov's three laws of robotics. Surprisingly, Asimov is a story writer, and he imagined the robots, and then so he is considered to be the father of robots. It was more a fiction in that he brought into all his dramas or the books that he uh, brought. And so the laws were evolved by him. A robot may not ensure a human being or through inaction allow a human being to come to harm. That means a human is always protected and a robot at no cost must harm a human being. A robot must obey the orders or the orders given to it by human beings, except where such orders would conflict with the first law. If the robo is programmed to go and hit somebody, then the robo should not follow that. For example, the movie Enderon, where the second robo was programmed in such a way that it should go and kill other people. Now, that kind of things are not welcomed, and it is against the law. A robo must protect its own existence as long because of its protection does not come in conflict of the first and the second law, right? So moving on, we also saw the anatomy of robo, where we had a base, and then we have the shoulder part and the elbow and the wrist. Like a robo is generally considered to be the arm portion of the human being. I have the shoulder, the elbow, and the wrist. Okay, this part, as we discussed, is the end effector, which will be designed in such a way that to work for a specific purpose. Okay, so moving on, what are the selection criteria of a robo? The selection criteria is based upon the application. Okay, so if it is going to be used for painting, the number of axes that is required, the repeatability issues, and how it is to be mounted, etc., are all given. I have given here some links here where it takes you to the website where the detailed selection criteria or how do you go and specify and then buy a robo has been given there. Okay. Now, roughly for the academic purpose, it is enough that we understand that robust is specified by the accuracy, the resolution that it can undergo, the repeatability, how it can come to the same point multiple times. Okay, so then the speed and the payload. Payload is the amount of weight that it can carry. Okay, now the number of degrees of freedom. Okay, geometric configuration of the manipulator, maximum and the minimum reach. Now sitting here, I can stretch my hand and then I can reach only a certain distance. Now that distance is the total reach. It is not that I get up and go nearby, but then I have to the robo is stationary and how much is the area that it can reach. Okay. Now this is also called as the envelope of the robo. The type of drive system, okay, and the type of control system. Now these are all the specification of robots where before when you go and buy a robo. Now, how the continuing with the selection of robots, depending on application also you can look at the robo. If the application is for arc welding, you see the arc welding robo is here. Okay, what is the anatomy? Like whether it is a polar configuration type of robo or a revolute kind of configuration. Number of axes, whether it is 5 axes or 6 axes. What is the number control system? Whether it is a continuous path or a spot welding kind of a robo. The drive system, whether it is a electrical or hydraulic, and whether it is a manually programmed one or powered lead through. Powered lead through means I'll be able to teach in the robo. I will say this is the point that you'll have to go. It will register that point based on the coordinates, and then it will try to reach that point back again. Okay. The next one is the spray coating. In spray coating, the anatomy, you have the revolute joint, number of axes is 6, control system is continuous path, drive system is hydraulic, and the programming is manual and bleed through. Assembly type of robots are there, quite interesting. I think we'll come back to this again there. It is called a SCARA robo. Selective compliance assembly robo arm, it is called as. And then, it is a special kind of a robo. The number of axes is 4 to 6, point-to-point system, or it could be a continuous path one, electrical driven, and then it is powered through lead, textual language, and accuracy and repeatability is very high because of the assembly. Okay. Again, depending on the factors, and then what is to be considered is also given here. If the parts are to be handled is based on the weight, based on the shape, changes in the shape during the processing, then the tolerance in the part size, etc. There, surface condition, protection of delicate surfaces. It can even handle an egg there. Okay. What is the actuation method? How do you make the movement, initial movement, or the movement how it has been driven, whether it is a manual grasping or whether it's a vacuum, holding, or whether it's by magnet. Which type, is it going to be? Or then the power in the signal, whether it is a pneumatic, electrical, hydraulic, or mechanical. What type of power it is going to be used? Then the grip of force, again depending on the weight of the object, the method of holding, the coefficient of friction between the fingers and the object. If I want to hold something like this, how do I, what is the coefficient of friction? Should it be, should it hold, the friction be high or friction be low? A robo end effector can even hold a delicate egg. Okay, an egg it can hold. That means it understands the surface there, and then it knows how much amount of holding force that it has to apply. It understands that. Then the length of the fingers, in inherent accuracy and repeatability of the robo, and the tolerance on the part size. Now, moving again, service conditions, number of actuation, lifetime, replaceability, maintenance and serviceability. This is one point which people take into effect when before they buy it. What about the service conditions? What about the operating conditions? Whether the heat, temperature, humidity, moisture, dirt, chemicals, etc. Where this is going to be used? What about the temperature protection? Whether is there any heat shield law? Whether there's some kind of a force cooling, compressed air, water cooling, etc. Then, what type of heat resistant materials that it should be made of. Then, fabrication of material, strength, rigidity, durability, fatigue strength, cost and ease of fabrication, friction properties for finger surfaces, compatible. Now, up to this level only the robo's arm comes up. Now, this part, after the wrist, the end effector can be tailor-made, and then even if this gets worn out, it can be taken out and then again refixed inside. Okay. What are the other conditions? Use of interchangeable fingers, design standards, mounting connections, etc. Spare parts availability, maintenance, and service. All these things goes into the factors that is to be factors and consideration to be done before selection of a robot. Now, the various configuration of the robo is given here. You see the Cartesian robo where all our linear movements are there, all the X, Y, and Z. You have the cylindrical robo. There's a rotary movement, and then there is a linear, two linear movements are there. Okay. You also have the polar or spherical robo where there are two rotary movements and then one linear movement. And then you have the SCARA robo, which I talked about, the selective compliance assembly robo arm, where there are two rotations and then one this one. It's very similar to this one, but it is more specifically used for assembly purposes. Then there is the anthropomorphic robo or the angular robo, which is also called as the spherical robo, where you have all the three angles of will be catering for rotation. There is no linear movement there. Okay. Now that comes to this end of our this presentation. We will just summarize what we have studied. We talked about the robo anatomy. We have talked about its specifications, the various configuration we just looked about, the various the Cartesian, cylindrical, polar, and the articulate type, and we try to understand how do we try to buy a robo based on its the specification and the application that it is going to cater. Okay, so thank you very much. We will meet again in the next episode, in which is a continuation of the same unit. Thank you very much.